All right, silly people, here's the situation. Uh, this problem has a lot of stuff dealing with binomial coefficients in it, right? So first of all, we need to write a Python function that actually does calculate a binomial coefficient n and k. That is n choose k equals n factorial over k factorial times n minus k factorial. Useful in statistical mechanics or stuff like that. Um, so first of all, since we see that this whole thing is dependent on factorials, um, we can just use the factorial function given in the text that Mark Newman came up with. So that's this. I just copied it from the book. There it is. And we're just going to make the binomial function from that, right? So def binomial, and then it has to be n and k for the arguments. And it's going to be n factorial. So, well, first of all, actually, it has to return 1 when k is equal to 0. So let's make an if statement. If k equals 0, then return 1, right? But then otherwise, we use the formula, which is going to be n factorial. We're just going to type it in as factorial n, and then divided by k factorial. So factorial k times, it's the factorial of n minus k. Yeah. Factorial n minus k, right? Awesome. Pretty cool stuff. So we need to use this function to print out the first 20 lines of Pascal's triangle. Wow. And it says the nth line of Pascal's triangle contains n plus 1 numbers, which are the coefficients n0, n1, and n will choose n, so on. Okay, so we know we're going to need a for loop, and it's going to run from 1 to 21, I think, for n in range 1, 21. That way it does n equals 1 all the way to n equals 20, right? And then also another for loop in here that's going to run over values of k. So for k, and we only want it to run from 0 up to the value of n. So it's going to be for k in range, just n plus 1 should do it. Yeah. Then it wants us to calculate a bunch of, binomial coefficients. So what I'm going to do is I'm actually going to create a list. It's going to be an empty list for now. But as we calculate binomial coefficients, we're going to put in elements of the list that are the binomial coefficients. So the first element would be the binomial of n, k, and actually that'll be all of them. And then after that gets done running, it needs to print out the list, but we want it to not be a list when it prints out. We want it to be a string. So what we can do is we can say star list. That way it prints out every element of the list. And since Mark Newman, he wants us to have the numbers separated by little spaces, we'll just put a little argument in the print function as sep equals quotation marks with a space in between. That way, whenever it prints out each element of the list, it separates each one by a space, right? And then that should be good. Let's give it a run, see what happens. It prints out floats. Let's make sure it prints out an integer value of the binomial coefficient. That way it's a lot prettier. But yeah, that's Pascal's triangle in all of its chunky glory. The next thing is to calculate some probabilities now. The probability that an unbiased coin tossed n times up heads k times is the binomial nk over 2n, right? And then, so we're going to write a program to calculate the total probability that a coin tossed 100 times comes up heads exactly 60 times, first of all. So this isn't totally necessary, but I'm going to copy the functions down to the next cell. Treat this as a completely different code. Wants us to calculate the probability of 100 choose 60. So let's just do binomial 100 choose 60, and then divided by 2 to the 100 to get that probability. And so we'll make a print line p, and it prints out something like 10%, which is, that's okay with me. Then also print the probability that it comes up heads 60 or more times. So now we actually have to run over values of k from 60 up to 100 and then add up all the probabilities from that. So again, I'm just going to copy down the function definition lines to the next cell and make a for loop now for k in range. Have it go from 60 to 100. So 60 to 101. That way it gets the last element. And then p plus equals binomial 100 choose 60, or not even choose 60, choose k, and then divide the total answer by 2 to the 100, right? Okay, and then after it's done running through the for loop, it'll print what p is, and that is looking like 0.039% chance of that happening. So cool stuff there.